All right, for today's lesson, we're going to do a continuation of our areas, but we're going to combine them now with some things. So let's go over the drill. Hopefully these were relatively basic. The first one, area of a circle. Area equals pi times the radius squared. It looks to me like that 18 feet there is representing the diameter. So the radius is going to be half of that. So the area is going to be pi times 9 squared, and 9 squared is 81, so the area is 81 times pi, or again, if we're going to give a decimal approximation, you're going to type 81 times pi into your calculator, and you should get an approximate area of 254.47, and we do have a unit on this one. It is feet squared. All right. The next one looks like it, number 2 is a parallelogram. It looks like our base is 4 and our height is 9. Remember, the area of a parallelogram is just base times height. So the area is going to be 4 times 9, which is 36, and it does have a unit. It'll be feet squared. Number 3 definitely is a triangle. The area of a triangle is 1/2 the base times the height. So we'll do 1/2 of the base, which looks like it is 7, and the height, which looks like it is 10. So 7 times 10. And 1/2 of 7 times 10. 7 times 10 is 70, and half of that is 35 yards squared. And then the last one, it is definitely a trapezoid. I've got two parallel sides where the 8 and the 11 are. Those are your bases. So we'll call this base 1, base 2. The height goes straight up and down in between the bases so that it's perpendicular. So the height here is 6. The area is 1/2 the sum of the two bases times the height. So 1/2, let's add the two bases together. So 8 plus 11 times the height of 6. So that's going to be, let's see, it's going to be 1/2 of 19 times 6. Whoops, kind of erased it there. And that's going to be, let's see, 19 times 6 is 114, and half of that is 57. So it'll be 57 yards squared. All right. Those should have been hopefully pretty easy. You're just plugging in the numbers into the formulas. All right, so you should have received a sheet that has this on the front, and it's got another one of these things on the back with numbers on it. But the first thing we're going to do is take a look at the one without the numbers. And the idea is if we needed to find the area of all of this, so we need to find the area of kind of that shaded region there, we need to come up with a nice way to do it. There's a whole bunch of different ways that you could do this. So what I would suggest before you actually watch the rest of this video is start by drawing a line from one point on this graph to another point on this graph somewhere so that it starts to basically cut this thing up into nice, easy geometric shapes. For example, I will give you one of them. It would be really nice if I took a line and I drew it from this corner right here straight down to here, because hopefully what you can see is that creates a nice little right triangle right here. So we have a way to find the area of that piece right there because it's just a triangle. Now, if you can cut this thing up into a whole bunch of different easier geometric shapes, it's going to make it real easy to just take the areas of all the little pieces and then add them together. So take a minute, actually look at this thing, try and split it up. There's so many different ways you could do it, and there's lots of right ways to do it. So give it a shot. Okay, so I'm going to start now. Hopefully you paused the video and did it that way. There's a whole bunch of ways you could do it. So I could, from here, draw a line straight across there. That would give me a rectangle up here, a rectangle here, and a triangle to add up. Easy enough. I could do it that way. Maybe you saw to do it a different way. Maybe you decided instead to put your line straight down here, which gives me this rectangle and this rectangle. So either way, it's still two rectangles there, and then that triangle. Again, there's a whole bunch of other ways to do this. Maybe, trying to erase this real quick here, maybe you saw it a completely different way. Maybe you said, well, what if I put a line right from this corner to the other corner? Probably not the easiest way, but you would have a trapezoid in this part, and I would have another trapezoid up here. Just know that the bases would actually be there and there on that other trapezoid. Again, there are so many different ways you could break this thing up. And that's kind of the point, is that you could do it in a whole bunch of different ways. I didn't even have to have this original triangle right here. I could have just made two trapezoids out of this whole thing. That would probably be the minimum amount of lines that you would have to use. If I just simply went from here up to there, I've got one big trapezoid here, and then another trapezoid over here, and I could have just done two areas. All kinds of different ways. Does not matter how you choose to do it, as long as you come up with the correct geometric shapes. So, whatever way you broke it up, that is your choice. And there, again, there's probably even more than what I just did there. So now, go ahead and flip it over to the back. And we've given you some actual dimensions. Now you can use these dimensions to hopefully be able to figure out what the actual area of this whole thing is. So depending on how you decided to break it up, we're going to be able to find the area. I'm going to show you one way, but maybe you chose a different way. So again, I am going to go ahead and split this up. I'm going to draw the little line right here to create a triangle. And I'm going to draw a line straight down here to create a rectangle. So now I basically have two rectangles and a triangle. The biggest thing is we have to make sure that we have all the correct dimensions. The rectangle on the right-hand side, the tall one that's kind of over there, that's the easy one because it looks like I've got a base or a height of 10, excuse me, and a base of 5. We can figure that one out. This one right here is going to be 5 times 10, which is 50 feet squared. Now we got to figure out the little triangle on the left and the other rectangle. Well, with the other rectangle, it's definitely got a base of 7. And you might be thinking, well, what about this 15 down here? Well, that 15 actually represents that whole area right there. So that's not really going to help us with that particular rectangle, with this one. What we need, however, is we need this height. We have to do a little bit of thinking. The entire side of this big rectangle here was 10. But I also know that this piece over here down to there is 6, which means that the remaining piece of that is your height. So what do I have to add to 6 to get that whole 10? I'd have to add 4. So this height here is 4. So now I have base times height. And that'll give me the area of this particular rectangle. So that is going to be 7 times 4, which is 28 feet squared. Last thing we have to do is we have to figure out this triangle. Well, in the triangle, we need 1/2 base times height. Okay, the height is going to be the same as the height that we just did. The height over here is also 4. It's this little piece right here. That is our base. That's what we have to figure out. Well, I know that the whole bottom, like I just did over here, is 15. I also know that this piece right here is 5, and this piece is 7. So if I do 5 plus 7, that's 12. What do I have to add to that to get to the whole 15? That's 3. So I know that my area of my triangle over here is going to be 1/2 the base of 3 times the height of 4. And that'll be 1/2 of 12, which is 6. And again, it's feet squared. That goes in that area right there. So now we have all the different areas. I'm going to circle those in purple. That or blue, I guess, sorry. That's the first one, that's the second one, and that's the third one. So if we wanted to find the whole area, we just simply add them all up. The area of the entire thing will be 50 plus 28 plus 6, which is going to end up being 84 feet squared. Okay, so that's the area of the entire shape there. So now, if this is going to be our deck, and we actually want to go ahead and purchase the material for the deck, which is the question at the bottom, it's telling us it's going to cost us $50 per square foot. Well, now I know how many square feet I have. I have 84. So if you want to know the total cost, you're just going to multiply your 50 times your 84. So the cost is going to be 50 times 84. And we have to do 50 times 84, which is going to work out to be $4,200. That's how much it'll cost us for the materials for the deck. All right, again, and here's the big thing. If you chose to do this in a slightly different way, no matter which way you did it, your areas might end up being a little different for the different parts, but they should all always add up to 84 because that's the actual area for the deck. And then you multiply that by your 50 to get the cost of $4,200 or $4,200. Hopefully you'll see that. Maybe somebody else around you did it in a slightly different way. As long as you got the same answers, that's okay. All right, so that's the kind of the concept here of what we're doing in this lesson is we're taking things which are basically called composite areas, meaning you're going to take some kind of a shape and break them up into smaller, easier shapes and just add them all together. So a really quick reminder, area of a parallelogram, that is base times height. Area of a triangle is 1/2 of the base times the height. Trapezoid is 1/2 the sum of the bases times the height. And a circle, kind of has nothing to do with any of those, is pi times the radius squared. All right, so now let's take a look at a few more figures. And the idea is, hopefully what I want you guys to do is I want you to pause the video, try and draw lines so that you're going to create some easier shapes to figure out. The less shapes you can draw, the easier it usually is to do. So you want to try and do it with a minimal amount if possible. See what you can come up with, and then unpause it and we'll see how I did it. Okay, hopefully you had a chance now. So the first shape there looks like it's kind of got this little circle-y piece on the left side and then like a rectangle piece on the right. So if I were to simply draw, oops, come on, draw for me. Uh-oh. Oop, pen might be dying. Oop, there we go. Pen's working again. See if I can draw a straighter line though. So again, kind of looks like I've got a half a circle over here and then a rectangle. So it looks like I got a rectangle here and then a semicircle or half a circle there. Okay, that might be one way to do it. Probably the easiest way in that case. It looks like in the second one, maybe I've got that half circle thing on top. not doing a very good job drawing straight lines here. So it looks like maybe I've got a half circle here, and then down here it looks like we have a trapezoid. You could split the trapezoid up even further and make two triangles and a rectangle or something like that if you want to, but either way, those are geometric shapes that we can do. The one on the bottom here looks like if I simply just draw a straight line down, I'd have a rectangle over here and then a trapezoid over here. Multiple ways you could have split that one up. You could have done a whole bunch of different things there. So you might have come up with a different way, but that's just the way I saw. I think on this last one, it looks to me like the easiest way might simply be to draw a triangle on the left and then maybe split this one right here so that I have a rectangle and another rectangle. So triangle here, rectangle here, another rectangle right there. But again, you could have come up with completely different ways of doing this, as long as it makes geometric shapes that we can easily figure out. Okay, so let's go ahead and look at these last few examples that actually have numbers with them now. We want to find the area in each figure. This one right here, this big L, I'm sure that the easiest possible way is just to create two rectangles out of it. So I think it might just be easiest to do a rectangle there. So we have this guy and then this piece over here. Probably the easiest if you ask me. You might have done it a different way, but again, as long as it works, doesn't matter. So the area of the first rectangle, let's see. I've got a height here of 9. I do have to figure out this base right here. Well, I know that the whole thing all the way across is 10. I also know that from here to here, so that would be this piece, is 6, because that's right above here. So that means that that little piece over there has to be 4 so that it adds up to 10, because that would be 4, that would be 6 right there. So the first rectangle looks like it has an area of 9 times 4, which is 36 centimeters squared. It looks like the second piece, this rectangle, I'll color that one in green right there, looks like it is simply going to be a base of 6 from that piece right there times a height of 2, which is 12 centimeters squared. So if I want the total area, add those two things up right there and we get 48 centimeters squared of area. Okay, and these are all called composites because we're going to break them up and then add the areas together. Okay, this one's nice. It kind of split it up for us already. So the easy part should be that rectangle right there. Base of 15, height of 10. So the area is going to be 15 times 10. Let me see if I can write that a little nicer. 15 times 10, which is going to be 150 inches squared. We do have to figure out the area of that semicircle. And notice that it is half of a circle. The area of a whole circle is pi r squared, but that's only half of the circle, so we're going to multiply it by half or divide it by 2. So now we have to figure out what the radius is. Well, the whole thing here, that's the diameter of that circle, was 10. So half of that is the radius. That's going to go from here to there. That's only going to be 5. So the radius here is 5. So it'll be 1/2 of pi times 5 squared. 5 squared is 25, so that'll be 1/2 of pi times 25, and 25 times 1/2 is 12.5, so it'll be 12.5 times pi. And then again, if we're going to give a decimal approximation to this, which we can certainly do, just need to use the calculator and do 12.5 times the pi button, and that gives us approximately 39.27 inches squared. And then the whole thing is going to be adding that one with that one. So the total area of this thing is going to be 150 plus 39.27, which works out to be 189.27 inches squared. Again, there might have been other ways to try and split this up, but it did it for us. So that was the biggest thing we had to figure out there. All right, the third one, we have this arrow. Multiple ways you could split it up. I think the easiest way is simply going to be to create that vertical line right there, which is going to give us the triangle over here, and then this rectangle, which I'll put in green over here. The rectangle will probably be the easier part to figure out because the rectangle is going to be base times height, so 16 times 8. So the area of the rectangle will be 16 times 8, which is 128 meters squared. Then we got to figure out the triangle. Remember, the triangle's area is 1/2 the base times the height. So I'll do this in blue. 1/2 the base times the height. That's going to be the area of the triangle part. Well, the height is actually given to us. That's this piece right here, because that's telling us the whole thing from the very top to the bottom, if you kind of think of it as being on the side, is 16. So this piece right here, which would be perpendicular to that side, has a length of 16. That's your height. So we're going to put a 16 where the height was. 1/2 is still 1/2. Now we got to figure out what to fill in for the base. Well, the base is this part in red. The whole thing. Well, they told us that that piece is 3 and that piece is 3. So what's this piece right here? Well, that's the 8 from over here. So the base is the 3 plus the 3 plus the 8, which is 14. So that is going to go in for my base. And then we're just going to simply type all that stuff in. We're going to get 1/2 of 14 times 16, which works out to be 112 meters squared. So the total area is 128 plus 112, which is 240 meters squared. Again, there might have been other ways that you broke that one up, but that's probably the easiest way that I could see to do it. And if you broke it up in a different way, as long as your area works out to be 240 meters squared, then you've done it right. All right. Your homework on compound shapes is going to be due next class. It's on the handout. Show all the lines that you use to separate your shapes, and then show your work to receive full credit on your homework, meaning show me what formulas you used, like 1/2 base times height for triangles, base times height for parallelograms and rectangles, and so on. Other than that, that's the lesson.